Hello everyone. So in this video we're gonna talk about ECS microservices. So in this project we have to make 6 microservices in a single cluster using ECS. So it will have 6 pipeline for 6 microservices, and also we will use one load balancer for handling all the microservices, and will apply auto scaling as well. So with the help of this documentation we're gonna talk about these microservices. So basically, what is microservices? Okay, microservices and are an architecture and organizer approach to software development where software is composed of all small independent services that communicate all over well-defined APIs. These services are owned by small self-contained terms. Microservices make application easier to scale and faster to develop. So in this infra, we are going to build is composed of the 6 microservices like service A, service B, C, D, E, F. So we are going to use ECS for container and will deploy all the microservices in a single cluster. For this, we will have 6 pipeline also, one for each responsible for building, testing, and microservice, and each pipeline will be deploying on the respective microservice. So here are a few steps that are followed for this infrastructure. Like in step one, we have to create a VPC with subnets and also required IAM users, ECS cluster, load balancer, target group. So for this, we are using Terraform. So basically, what is Terraform? Terraform is an infrastructure as code tools that allows you to build, change, and version infrastructure safely and efficiently. This includes low-level components such as compute instance, safely efficiency, storage network, as well as high-level components. So in the next step, we also go for the ECS and ECR. So basically, ECR is Docker Container Register, which is easier to store and share and deploy container images. And the next one is ECS. The ECS is defined and ready for image for containers. It is time we set up ECS cluster. So in the next, we have also use AWS CI/CD tools. So in this AWS code commit, which manage repo, that is source, and AWS code build, AWS code deploy for the deployment service, and the AWS code pipeline, that is workflow management. So in the Terraform instruction, that we keep in mind that firstly we have to show AWS CLI is installed and you have configured authorization properly. After that, initialize Terraform. From the Terraform folder, run these three commands like Terraform init, Terraform plan, Terraform apply. So basically, Terraform init, after initialization done, change variable values. You will find a variable.tf. After done with the changing variables parameter, it's time to do sui verify what resource this will create. For this, we will have Terraform plan. Verify once if same wells, it's time to create actual remote infrastructure in AWS. So this is how created infrastructure for this project. Or at the end, we have our 6 pipelines are created for this infrastructure. So let's have a look to our code. So basically, this is our first services, and I'll name as ECS microservice as short form ECSMS.tfe. So TF is basically for the Terraform. So this is our ECS cluster. As you all know that we have using only single ECS cluster. So this is our service one, in which we have to put resource, network configuration, and we have to touch load balancer. So in the network configuration, we have subnets like public security groups and assigns is true value. So for the resource easiest definition task for the CPU 256 and the memory is 512, its execution. So So as similar, we have to use it for the service too, in which we have to also put resource, network modes, container definitions, name, which is service to, and the CPU 256 and memory 513, and the resource AWS ECS services. So for the very first step, you have to create a Docker file in your project. Like I have created in a Docker file Docker 1 to 6, like Docker 1, Docker 2, Docker 3. For the ECS, we have to populate it with the following code. So this is our source, in which we have source type is GitHub, and location is our GitHub repo link. So another one is resource AWS code pipeline, and name of this is my pipeline in this for artifact, and the store and the source in the build and the deploy part. So the next one is auto scaling. So in which we have two resources auto scaling, like AWS auto scaling policies, scale up policies, in which the name of scale up policies and which depend on AWS auto scaling, then the resource ID, scalable dimension, step scaling, step adjustment, metrics, environment load bound, and scale adjustment. Yeah, so this is for in the next service as similar as, but we have to just change in our name, like task 2 in the previous is task 1. So in this resource we have to just change our name. All over the code is same as service 1, 2. They all are same. This is similar as the previous. So in this we have also put our resource in, and the name of our service is services 3, and the cluster and the task definition and the desired count is 2, and the launch type is Fargate, ECS Fargate. So the next one is network configuration, in which we have subnet security group assigned public IP, which is true, and the load balancer, in which we have to uh, set up our target group ARNS, container name, that is service 3, and the container port, which is 80. So in the next we have artifacts, environment, log, S3 log, source, as you all know that our source type is GitHub, and the next is our GitHub location. So in the next one is code pipeline. So this is basically 6 services, in which we have create a 6 pipeline as well. So this is as similar as source, build, deploy, resource, auto scaling policy, and auto scaling target. So the resource is AWS auto scaling, and the next one is auto scaling policies, and next is cloud AWS CloudWatch, in which we have to set up our CPU utilization threshold. So the another one is service 4, which is ESMS4.tf, in which we have the first resource as AWS ECS task definition, and the name of this task is task 3, and they have network configuration, CPU, memory, execution roll on, container definitions, CPU, memory, container port X, And the next one is a resource for our service 4, and the name of the service is service 4, and the cluster ID, task definition, desired count is 2, and the launch type is Fargate. And the next one is network configuration, in which we have subnets, security group ID, subnet ID is assigned public IP, which is true, and the load balancer, and the artifacts, and the environment, and the logs, which is S3 logs, and source type is GitHub, and the location is our GitHub repo link. And the next resource is for our code pipeline, and the name of pipeline is pipeline 3. And the next one is artifact stores code source build deploy. And the next is auto scaling, ECS target 3, and the auto scaling is for the policies. So this is a CloudWatch metrics alarm. So this is our service 4. And the next one is our service 5, and the name of this is task 4. And so this is all you know that now. This is our code in which we have to put some resources, load balancer, and our source for the pipeline, and the source type, which is GitHub, and location, and the CloudWatch, etc. etc. So this is our service 6, which is as similar as previous services. Yeah, so the next one is I'm.tf. So basically for the code build is necessary to create an IAM role and policies to allow access to ECR to push and pull the Docker images. In the ECR repo, also it is necessary a permission to access a S3 bucket to store the artifacts. So this is resource. So and policies JSONs, in which the effect allow. So the resource is IAM role code pipeline role. So this is our IAM role and policies. This is basically important step. The next one is load balancer. So the load balancer security group will only allow traffic to the load balancer on port 80, in which we have the target groups listener. The address block within the resource block traffic from the load balancer will be allowed to anywhere, any port with any protocol with a setting in the S block. So there are some target groups like target 1, 2, 3, and the listener, and in the action in the condition that query strings like path pattern, and the values is, as you know, that index.html. And the target group 4, in which the resource we have to put in the name, port, protocol, VPC ID, target type. So as similar in the target group 2, 3. So in this we have to condition query strings and key values. So the next one is policies.ef. So in this we have to put our AWS mdot policy for the code build. So the name of this is unique 2, and the policies for the pipeline, and the name of our pipeline is unique 3, and assume for the role versions. Effects allows. So this is our policy. So this is our provider. As you all know that AWS is our provider. So the next one is S3 bucket, in which we have the resources, bucket name, etc. So the next one is security group of load balancer, in which we have the security group for the application tasks specified that it should be added to the default VPC and allow traffic over TCP to port 3000 of the application. The in-case setting also includes the security group of the load balancer. So the next one is variable.df, in which we have to declare variables and description and their defaults. So so the next one is VPC, which is virtual private cloud. So in this we have to put resources, which is AWS VPC, create VPC, and the CIDR block, then the instance tendencies default, then the enable DNS host name, which is true, and the tag and the name of the VPC, and the Terraform VPC is my VPC's names, in which we have the resource for the root, and the tags and the name of this is public root table. And the next one is for the subnets. The first one is a public subnet, in which we have the VPC ID and the CADR block and the availability zones and the tag and the name of the public subnet. So the next is similar as the second public set network, and the associate with the root table association table A, and the next is table 2 for the red table. So these are some phrases for the ECS 6 microservices. So for this so after this you have to use Terraform 33 command, which is Terraform init for the initialization, Terraform plan, Terraform apply. We talk about this in the documentation, what are the implementation of these commands. So